Right, welcome back, guys. And today I'm going to give you an overview of everything. 5 rules to write clean code. Somebody just popped me a question saying, "Hi, Prof, can you do 5 principles of becoming a master in writing clean code and writing modular code?" Right. So then I was like, okay, then I will find some time in between and give you guys 5 rules to write clean code. Remember, as a software developer, clean code is very crucial in software development because it's going to enable your code readability, maintainability, and scalability, and all liability. So it's not just about making the code work, but ensuring that it can be easily understood and modified in the future, writing reusable code. So then the 5 key principles to write clean code. Um, in my decades of experience is the SOC and DRY, which is dry, and keys, which is the ISS, and DYC, and YAGNI. So let's start with this. Okay, let's just do it like this. 5 rules to write clean code. 5 rules to write clean code, right? Let's do it like this. Let's do it like this. Okay. Think it's visible enough for you to see. So yeah. Let's look at the 5 rules to write clean code. So then we have got the SOC, dry, keys, DYC, and YAGNI. So then we just need to start by our very first rule. So let's look at the first rule. Let's look at the first rule just for me to break it down for you. There's rules everywhere. There's rules everywhere. There's principles everywhere. So then let's say rule 0. We start counting in 0 in programming if you didn't know. So then that's SOC. So then SOC is the separation of concern. So then separation of concern in programming is about breaking down a code base into distinct section or segregated parts, each responsible for a single functionality. Imagine you are building a house. Let me give you a real life um, example or scenario. Imagine you are building a house, right? And you wouldn't ask a plumber to handle the electrical work, right? So then same here in programming, you shouldn't have one piece of code trying to manage everything. You can't write one piece of code trying to manage front end and back end at the same time. So it's impossible. It's impossible. So then let's say SOC, that's an acronym for separation of concern. Separation of concern. Let's just proofread that. Then we have that. That's separation of concern. And looking at this SOC or separation of concern, for example, in a web application, the front end should handle user interactions and visuals only, right? So then you can't have front end doing back end work, or you can't have that piece of code trying to run front end and back end at the same time in one single piece of code. That's just a trash. you need to abide by the principles. So, and in the back end is where you manage your business logic and your data storage. So then by separating these concerns, you ensure that chances in one area don't break another area. You need to have that great balance in between of both. And it makes it easier to test and maintain your code. So then in a code, what you have to do, the SOC would mean separating user authentication logic from data retrieval, or isolating whatever error handling from the main flow of your program. This way, you achieve the cleaner and more organized code, which is easier to debug and extend the code, right? I think you have extracted clarity as to what is SOC in programming. So then let's go to rule number 1. We count from 0 in programming. So then let's do rule number 1. So then rule number one, we call it dry. So dry, it's what we call it, don't reinvent the wheel. Don't repeat yourself. So dry is about reducing repetition in your code. You do not have to repeat yourself. So it's all about reducing repetition in your code. It emphasizes creating reusable components instead of duplicating logic. You don't want to find your code consisting or entailing thousands and thousands of same logic, or triple or duplicates of logic. So then think of dry like a central library, right? Instead of printing copies of a book for each student, you let them borrow it from one place, right? So in a code or in programming, instead of repeating the same calculation or logic, extract that into a function or a class. For instance, imagine you are calculating the tax for purchases in multiple places. Instead of hard coding the tax calculation everywhere, you will end up creating a calculate tax function that you can reuse everywhere. So then by avoiding repetition, you reduce the chance of errors. By updating your code, it becomes more efficient, and you only need to modify the code in one place, and making maintenance much easier of your code. So then with dry, we call it don't repeat yourself. Don't repeat your. Let's just fix the casing here. So then we call it don't repeat yourself. Don't repeat yourself. So then that's our rule number 1, and then let's quickly jump on to rule number 2. So let's do rule 2. This is my favorite rule of all time. I call it kiss. Just listen to that. That's a kiss. So then keys in programming, it's keep it simple, stupid. You heard that, right? So then keys means that your code should be straightforward and easy to understand. Overly complex code or too much complicated code leads to confusion and sluggish code which is not efficient. Everything is just too complex. So it can be a nightmare for other developers to grasp what is supposed to happen here. What are you trying to achieve with your code? So then your code should abide to the keys rule. Keep it simple, stupid. So let's say keep it simple, stupid, right? So for example, let's say you need to calculate the sum of an array, and a simple loop or a built-in function can achieve this, right? But an overly complex algorithm that you may think, no, let me be smart, let me show them that I am that guy. No, you don't do that. We don't do that. You are overcomplicating simple things. So then, but with unnecessary abstraction, we'll just overcomplicate things, and simplicity is the key here in keys. So then, let me give you a simple example. Think of it like explaining direction to a stranger or someone who is not from your hood or your village, right? If someone asks you how to get to a location, you provide a clear steps, not a complicated set of options that you will tell them go straight and then 10 left, and then on your left you will see Jesus Christ sign on your left, and then look above you will see the sky is blue, and then look down and walk, and like, don't try to overcomplicate things. If you are giving someone instruction, just say go straight, 10 left, 10 right, you will find where you're going, right? So then you need to think of it like explaining direction in a total stranger who knows nothing about where they are going, right? So you need to provide clear steps, and make sure not to confuse them. So then similarly, writing code that does exactly what it needs to. Do not overdo it, don't less do it without over engineering everything. There are people who over engineer anything, even if it's just a report to extract something. Someone will then try to over engineer everything. Don't do that. Don't do that. So then that's just my favorite rule of all times, which is keys. All right. So then let's quickly move to rule 3. So rule 3, let's just change it to 3. Let's just change it to 3. So then rule 3, we call it DYC. So then the DYC, it's mostly important step of the code, right? So DYC, it's document your code. Document your code. You are not God who's going to remember what happened in 1903. So you will not be able to remember what happened in 1865. So you need to document your code, because the code you're writing today, if someone were to come and ask you a couple of years later why you had named this variable process transaction, you will not be able to remember why did you choose process transaction instead of whatever simple variable name. So then document your code steps by steps as you code. Then it should be much easier for you to understand how everything needs to be self-explanatory. Even if you were to hand over your code to the next person, they just read the code comments and then they get to understand your logic as to how you're trying to go about this code, right? So then the DYC, clear documentation, is very, 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 very crucial. It's very essential in coding, in fact. So then when someone new looks at your code, they should be able to understand the purpose of each part without much guesswork. Remember, coding is not a guesswork. We won't be able to be guessing as to um, how, what were you trying to do here. What you just need to have comments there for simple stuff. So a well-documented code communicates your intent simply. Deliver that clarity. The reason behind certain decisions and details on what each function or class does. For example, consider a method named process transaction without any comments or context. It's not clear as to what is exactly being processed here or what kind of transaction it is. By adding a simple comment describing its purpose or even input parameters and expected output, you make it clear for the next person not to do guesswork as to what was being processed here by this person, right? So then, however, balance is key, and don't over comment to the point that the comments become distraction um, in your entire code. When we look at your code, we now see more comments than the actual code. So then just try to find a balance to comment your code nicely, simple. So refer to the rule number 2 for you to do rule number 3. So then the keep it simple, stupid applies to rule number 3 where you document your code, right? So use meaningful names and provide context anywhere necessary. So then let's just define this. It's document. Let's just fix the casing. It's document your code. Simple. So then you document your code. Let's quickly jump to number 4. Let's quickly jump to number 4. Let me just change this to 4 and have this wiped out. So number 4, it's your YAGNI, right? It's YAGNI. So you can read it as YAGNI or YAGNI. It's up to you. So then this is what we call it. You are not gonna need it, or you ain't gonna need it, in simple terms. What does this mean in coding, right? So then YAGNI, it's all about avoiding necessary or unnecessary features or speculative additions. So you do not want to find yourself putting unnecessary features. You need to focus on the spec of what is needed in this code build. All right. It is tempting to think ahead and add extra features to future-proof your code, right? But that often leads to more complexity and wasted effort. So then, with these rules, they interrelate or correlate to each other. So then if you follow rule number 2 precisely and adapt to rule 3, it will guide you as to how you treat rule number 4. So then you do not need to over engineer the solution. So for example, if you are building an e-commerce platform for a single region, and you decide to add support for multiple currency, where is the sense there? Maybe you are based in India, all right, and you are building an e-commerce platform, and you decide to support to add a support for multiple currencies instead of supporting the rupees in India or in China, Chinese yen or something simple like that. Remember, it's not a global e-commerce. It is a region, a single region platform. So you do not want to add extra future proof your code. Just try to make it um, simple. So then, thinking you might expand globally if there's no immediate need for it, this is a prime example of violating "you are not gonna need it" rule, right? Because this principle encourages you to build only what is needed for the current requirements. So then if something is needed in the future, then and only then should you implement it. Think of it like packing for a weekend trip. You do you don't or maybe feel the need if you're going to a trip and then you don't pack a winter coat, if you are just going to the beach. What will be I mean, what will you be doing at the beach with a winter coat? I think you're getting exactly what I'm trying to make you understand here. So then let's say you are you aren't gonna need it, right? Yeah. So that's your 5 rules. That's your 5 rules to write clean code. So then maybe in closing, let's just reconvene as to what is these 5 rules. So then separation of concern helps you organize the code. Have that at the back of your mind. The SOC is there to help you organize the code. So dry, it prevents unnecessary repetition in simple terms. And then the keys keeps code simple. Keep it simple, stupid. And the DYC make it easier for others to understand your code because you'll be documenting your code, right? And your YAGNI avoids unnecessary complexity, encourages viewers to apply this principle to their own writing, right? So I think you get what I'm trying to pass over to you, right? I believe there's couple of IDEs which helps you practice clean code, and also there's couple of books that you can read. There's couple of books that you can read to really get these rules into play. There's a book that I know. It's called Clean Code by Robert C. Martin. For you who would maybe really want to have that more in-depth reading of these rules, right? So that's it, and see you on the next one. If you have any question, just drop it in the comment section. I would like to assist. Thank you.